This podcast was taken from a recent webinar from our sister company, the Data Incubator. The Data Incubator provides boot camps, training, and certifications to aspiring data scientists, engineers, and analysts. Learn more by visiting thedataincubator.com.
I'm Ana. As Sierra said, I am one of the instructors at the Data Incubator. So I've been with the Data Incubator for several years now. I was in our New York office for the longest time, and I relocated to Berlin, Germany now. My background is physics. And from there, I kind of meandered into data science. And so if you join the program, I'd be very happy to meet you. As you all know from the title of today's webinar, we will be talking about data ethics. So data science tools and techniques are sort of used nowadays for all sorts of applications. Very many positive things that you can do with data science tools, drive business decisions, of course, solve problems that used to be too complex to solve. You can gain new insights, create new opportunities, boost revenue, improve customer service, all sorts of things. But using data also comes with responsibilities, and the field as a whole sort of continues to face ethical questions and challenges. And this is what we'll talk about today. So, sort of in general, ethics refers to the perception of something being right or good or just or unjust. In the context of data science, we are talking about the proper or acceptable or appropriate data acquisition, data storage, data usage, and that takes into account human rights as well as how to use machine learning and AI for greater good and not to harm. So data ethics basically asks, is this the right thing to do? Can we do better? The main ethical challenges that I will talk about today are sort of in three topics. Privacy rights is one of them. Often data that we work with is someone's personal information. It must be properly acquired and used while maintaining privacy. We will also talk about data validity. So data scientists are responsible for verifying to the greatest of our abilities that the data that we are working with and that we are using is indeed valid and not corrupt. And also algorithm appropriateness and fairness. I'll talk about models that are potentially perpetuating injustices. If models need to make ethical decisions, what are we choosing for them to prioritize? Things like that. We would like to think that using machine learning algorithms to perform jobs that used to be performed by a person will bring only positive outcomes like automating processes, cost savings, increasing speed, increasing accuracy, having a larger consistency. We hope or expect that an AI system is more precise and reliable than a human would be, and hoping that the outcomes are more fair and less prone to injustice or social prejudice. All of that, though, cannot be far further from the truth when data science tools are applied without us being aware of the ethical challenges that I'm going to talk about today. So we're going to start with data privacy. So in this context, privacy rights is about ethical practices regarding personal data and also just in general, the data that we leave behind as part of our sort of daily digital footprints. Yeah, we're, for example, just browsing the web, shopping online, or using social media, using a plethora of apps and just digital services that we use daily. All of that data that is being collected is sort of needs to be properly collected, properly stored. Data privacy rights is about how that data is used and also about data ownership. So it's best maybe to discuss this topic with a couple examples, a couple potentially problematic examples where data privacy rights are breached. So One of the first things we can talk about when it comes to data privacy, one of the first principles of data privacy, is that an individual has ownership over their personal information. It's just like it's considered stealing if you take an item that doesn't belong to you. It's not legal or ethical to collect someone's personal data without their consent. Nowadays, a common way to obtain consent is through digital privacy policies through which users will agree to a company's terms and conditions. Or when you visit a website, you'll get pop-ups asking if you agreed that a website tracks your online behavior with cookies. This can therefore then be legal for your data to be collected, but there are examples where this can still be problematic. Here's an example from 2014 when OkCupid revealed that as part of a social experiment, they at some point tested what happens when they tell people who are poor matches that they are a perfect pair and vice versa. And they said that they basically wanted to test if people fall in love because the app told them that they're a match, or was it the case that their matching algorithm actually correctly predicts who would fall in love and who would not? So it was basically testing their algorithm. When this came to light, many users were, of course, upset. OkCupid's co-founder at the time said, guess what, everybody? If you use the internet, you're subject to hundreds of experiments all the time on every site. That's how websites work. And indeed, the company's privacy policy does state that it uses data it collects to sort of research and test the effectiveness of its site. And most websites and apps indeed do this. And indeed, they do state this in the agreements we sign. So this caused some uproar, but they claimed informed consent because of the agreement that users signed when signing up for the service. There is a question here of really informed consent and what counts as informed consent. Apps and websites use lengthy terms of service to detail everything that they track, everything they might do with your data. And you're not alone if you do not bother to read that carefully and you just click accept. Many users don't have the time or the patience to read along this very detailed reports on every item. So when users then agree, did they give consent? They did. But as a user, though, it isn't informed consent per se. So the bottom line being, when companies then use this data in ways that users are unhappy about, this can cause serious issues, at a minimal, potentially reputational issues for the company. Another example of a data privacy topic is our right for the data that we leave behind to be stored properly and securely. An example of when things went wrong, and there are so many examples like this, unfortunately, where our data is not stored safely. One example is the April 2021 Facebook breach. So the personal information of over 500 million Facebook users was found posted online by a hacker, including people's names and birthdays and phone numbers and email addresses. And at the time, according to Facebook, they were claiming that that stolen data was originally scraped years before. It was due to some vulnerability that they already fixed in 2019. So people don't worry. We all still happily use Facebook, or some of us do, some of us don't. But this happens, unfortunately, quite a bit, where data is not stored as properly as it should be. Another topic when it comes to data privacy rights is data being collected, being sold. Data collection and sale of data are actually a huge part of the modern digital economy. From any online shop to just Google and again, Facebook and any website will use user data, and it's used for everything from sales to marketing to good looking up user experience, improving user experience, used for product development and other things. We are just each such a rich source of information for companies about what we like, what we buy, who we are. And companies collect that data about us nonstop. Yeah. What you click on, what you buy, what you post, who you match with on dating apps, what cars you drive in car sharing apps. Every company tracks everything you do. They collect that data either to use it themselves or to sell it. So you have likely experienced the results of this yourself, where you, for example, got a call from a telemarketer or somebody where you were wondering, where did they get my phone number? Or how some brand you never shopped at start sending you emails. So some of this selling of data can be illegal, but some of it is legal. So data can be sold to third parties. When this happens, though, without our knowledge or consent, it can be problematic. That happened in April 2020. New York Times article alleged that Zoom engaged in basically undisclosed sharing of the information with third parties during user conversations. Zoom was accused of transmitting a user's data to a third-party system that then matched that individual's information with their LinkedIn profiles. And apparently it did that even when somebody signed into Zoom as anonymously, their data would still be shipped to third party. The tool would still connect them with their respective LinkedIn profile, and therefore the person would sort of have their real name revealed to other users on Zoom, despite presumably trying to keep it private by logging in anonymously. So Zoom disabled the tool after the uproar. They removed it from their offerings. But the point here is that this tool was a third-party tool, and Zoom sent users data to there without sort of people being aware of that. So something to be aware of here as sort of another example of where things were not quite done properly. In general, customers or consumers typically have data privacy expectations. And some of the things that people expect is to be left alone. So to not have their data be collected and then be harassed by telemarketers and et cetera. To have our identity protected so that any sensitive information is protected. To have some control over that data. To be forgotten when consumers ask to be deleted from a database, they should be able to be forgotten. To know when they're interacting with AI, so that they know, am I talking to a human or is this some AI that I'm interacting with? And they also expect to know how that data is being used. This has had some sort of regulation in the EU, for example. EU has accepted this Europe's General Data Protection Regulation, or GDPR. So in EU, under GDPR, which is sort of designed for data privacy protections, companies must disclose the data that's being collected and disclose how the data will be used. The data that is being collected has to be minimized. So if there's something that the company is not needing and is not essentially used right now, they cannot be collecting that. Users get to be informed about the data that is being held. And users, when they ask to be removed, they need to be removed upon request. This kind of opens up a little bit of an interesting topic when you're talking about machine learning, because when, let's say, you have a huge database of users, you train a machine learning model on that data, then some of the users ask to be removed, you remove them. Does that mean you need to retrain the model? Because principle, that data was used to inform your model. So that can go pretty deep. And then lastly here, as you see, under GDPR, automated decisions need to be explainable, which is, again, another thing with machine learning. Some models have that interpretability and some don't. And under GDPR, when a user asks, why was I denied a loan? If that was an AI that made that decision, they have to get an explanation for why they were rejected, for example. There is no federal data privacy law like GDPR in the US. At the moment, there are some national laws, some laws that have been put in place to regulate certain sort of data in certain industries, but nothing like GDPR yet. But probably it's going in that direction. So what does that mean for sort of a practicing data scientist and data analyst individually? Data scientists and data analysts should be educated and equipped sort of with the knowledge and skills relating to data privacy. And that includes, of course, some security basics. This can mean just simple things like anonymizing data. Yeah. Every customer as they give your company, for example, consent to collect, store, and analyze their data, potentially personally identifiable information. That doesn't mean they want it publicly available, of course. Yeah. So, or that they want it used unless absolutely necessary. So here it's, of course, important that if that data is collected, to ensure that it is stored properly in a secure database so it doesn't end up in wrong hands. And one more step that can be done is de-identifying a data set. A data set is de-identified sort of when all these pieces of personally identifiable information is removed. So it's basically just anonymized the data. But all of that may not even go far enough, right? A privacy preserving data scientist would also have some training in techniques that allow models to be trained without potentially having direct access to the data or without having to copy that data to a central storage and instead just leaving the data on the device that captured the data, or learning to use techniques that prevent models from storing sensitive information about the data. So things like that. So this was about data privacy. The next topic I mentioned is data validity. So this is basically about, and this is a very essential part of any data handling, and it's about sort of checking whether you have the data that's valid and that is not corrupt. So it's basically trying to see whether you're, collecting information, analyzing data, or preparing it for presentations or whatever it may be. If you're working with data, if your data isn't accurate, you're not going to get good results, of course. So data validity is this practice of really checking the integrity and accuracy and the structure of your data before it's being used. So can the data that you have be trusted? Yeah. Or is it corrupt? In this case, it just means ensuring the data accuracy and quality. Just as an example, you may have features that are, let's say, self-reported, and that can be questionable. Yeah, if you ask people about their age or about their weight, or if you're trying to evaluate teachers by asking students how much they studied, for example, and you take how much students study as a feature, if students are self-reporting that, you have to ask yourself how valid that data is. Things like that. And also questions like, is the data representative of what we would like it to capture? It could be that I might just have a specific subset of the population that my data sort of is about. And that means that if I take that data and draw conclusions from that, I may get the wrong conclusions. Yeah. So for example, if I want to use Twitter feeds to represent public opinion, Twitter users are generally skewed toward probably being younger and richer than the general opinion or the general public. So either way, it's not a representative sample. And of course, also, is our data measuring what we intend it to measure? So all of that is sort of about data validity and is an important part of sort of a step in once we have the data to really ask these questions before we proceed to, for example, build any algorithms, any machine learning models. And speaking of machine learning models, there's sort of right next or third topic, algorithm appropriateness, algorithm fairness. Even when intentions are good, the outcome of a data analysis or a machine learning model can cause inadvertent harm. And this can mean to individuals or groups of people. And that's kind of what I want to talk about next. So fairness, appropriateness of machine learning algorithms. And maybe the first example I can give here when it comes to algorithm appropriateness is, let's say we think of self-driving cars. Self-driving cars will need to make split-second decisions to avoid endangering human lives. So what kinds of ethical principles we want them to follow? Researchers asked this question in a poll. It was a sort of a classic philosophical exercise that is known as the trolley problem. Essentially, they posed a series of questions or moral dilemmas to people involving, let's say you have a self-driving car that has brakes, but let's say that suddenly the brakes stop working. And they asked people, should then the car swerve to avoid a group of pedestrians, but which would end up killing the driver? Or should they kill the people that are walking on foot to spare the driver? So in that question, they added, does it matter if the pedestrians are men or women, or if they are children or older people, or if they are doctors or criminals, things like that. So just a general sort of classic philosophical trolley problem. On aggregate, people everywhere sort of pretty much believe that the moral thing is for the car to spare the young over the old, to spare humans over animals, and lives of many over lives of few, kind of a general trend. But there are some regional differences and cultural differences in how people answer this question. But either way, here, my point is that before we sort of allow self-driving cars to make any ethical decisions that they might be forced to make, we need to sort of be aware of this. And we probably don't want the car companies or the machine learning engineers alone to design these moral algorithms. We probably will all want to be part of this conversation if self-driving cars are the future. So just one example of model appropriateness. I want to give another example of the dilemma of algorithm fairness. So while we would like to think, as I mentioned at the beginning, that artificial intelligence means more precision and systems that are more reliable than a human, and also that the outcomes would be more fair and less prone to injustice. After all, machine learning algorithms are just sort of machines churning cold, hard data. Yeah. That is sort of cannot be further from the truth, turns out. An example of that is from the 1980s, where St. George's Hospital Medical School in the UK thought a computer program would make the admissions process fairer. Turned out to do just the opposite. So the main motivation was to make the admissions process more efficient and more fair, such that it would sort of remove any inconsistencies in the way that the admissions staff carried out their duties when they were doing admissions. So they, first round resume filter, the model was trained on screening records from previous years. So basically, from whatever the human panel did in the past was the data that went into the model, and the model turned out to be racist. So essentially, it turned out that race was actually not part of the data. It was explicitly taken out, but there were other features that were essentially proxies for that, like the model favored European sounding names and things like that. It turned out that it was just perpetuating what the human panel was already doing. So while it's not to say that unequal paths to opportunity are in general anything new, it's also not the case that using AI makes the injustices go away. So if anything, using AI on the real world data that is biased already, it simply just means that unequal paths to opportunity have now reincarnated as automated AI. Another example of that basically is predictive policing. The idea is that we have all of this data on crime. Why don't we plug that data into a machine learning algorithm and have a model that predicts crime, so that can predict in what area is police needed when, so that then they can sort of use their resources better and police can show up at the right place at the right time. Sounds like a good idea, yeah? But determining whether AI crime fighting solutions are actually a good idea depends on whether the benefits outweigh the risks that accompany them. And one of the risks with predictive policing is that any biased conclusions that can be drawn from AI can arise, and that can be based on factors like ethnicity or gender and age. So there are quite a few of predictive policing solutions or products out there. CompStat is one of them. It's a computerization and quantification program that is used by police departments, and it was originally set up by the New York City Police Department in the 90s. There is also a solution called PredPol, which is an algorithm that is supposed to make predictions based on existing crime reports. The problem with all of this is just that crimes aren't equally reported everywhere. And the readings basically that the data provides to law enforcement then basically could just simply copy these biases in reporting over an area. So when police, for example, use, let's say, predpol to decide where to patrol, they could end up essentially over policing areas that are already over policed to start with. So when these kind of algorithms were investigated, they were found to target neighborhoods with people of color and areas with higher rates of poverty. So the way that these algorithms work is that as police intervene in a given area, that is reported back to the algorithm. And as crime is found in that area, that basically is reported back to the algorithm as success, as the algorithm takes that as an indication that, oh, the predictions are correct, which means that it will just send more police to that same area, which just means that policing an area drives more policing in that area. So data is collected basically as a byproduct of police activity. Predictions are made on the basis of these patterns learned from this data and don't necessarily pertain to future instances of crime on the whole. It's that the model is basically selecting its data, its future data, and it's trained on that data, and as such, it's perpetuating bias. This is actually also it's called systematic bias, when you have a model that basically chooses its own data, and as such, just perpetuates bias. Another example of problematic algorithms or in algorithm fairness is the impact example. So in 2009 in Washington, D.C., public schools implemented impact. It was a new system for evaluating teachers based on their estimated effect on test scores of students. So this AI was composed, it made predictions, and then in 2011, 206 teachers were laid off for ineffectiveness. And that included several of teachers who had excellent classroom evaluations, great relationships with students and the school and the community as a whole. So here, right, the goal seemed good. We should weed out bad teachers. What could go wrong? The problem is that it's far too complex to measure a teacher's contributions to child's grades using AI. There's far too little data per teacher. You would need to test a teacher on thousands or millions of students if you actually wanted to get a good model. The features that were used were questionable. There were questionable proxies measuring student improvement. What measures student improvement? It was also shown that some of what they did was they used let's say, a last year's student scores and compared them to student scores at the end of the school year. And it turned out that some of the previous year's student scores were inflated because some of the teachers were basically cheating. So to make themselves look good in that year. So essentially, some of the students had inflated scores coming into a school year, which goes back to data validity, right, that we talked about before. So all of that was certainly a problem. And another very big, if not the biggest problem, is that there's no feedback. There was no feedback telling the model if it's doing right or is it off track. Without feedback, models basically will define their own reality and just kind of use it to justify their results. The model predictions were followed blindly. The teachers were just fired without actually having any feedback loop to measure if the model is makes even good predictions or not. So when we're talking about all of this, there's a couple crucial questions, I think, that need to be asked when it comes to model fairness. With our every move tracked, right, including the data, as I mentioned, from any interaction that we do digitally, also data from our genomes and patterns in our diet and our sleep and our exercise, obviously our spending patterns, our online browsing, all of that, right, is being used to predict whether we should get a loan, whether we are going to be accepted in a given college, to predict crime, how much we should sort of pay for our insurance, for example. And maybe it may seem like using AI with very personal data or individualized data sounds like a good idea. It's a move toward the individual. Everything will be customized and selective for each individual. The trouble is that it's not. It's not actually customized to the individual. People, if machine learning algorithms are used on human data like that, people are placed into groups that you cannot see, placed into groups that supposedly resemble us, so that fit us, based on some metrics and features that were chosen by the modeler, whoever put together the machine learning algorithm. So what is crucial here to be aware of or to mitigate some of these issues are, I think, one is, what is the objective of the modeler? Is the objective efficiency? Is it making more money? Usually. Is it fairness and ethics? Usually not. Yeah. And it should be all of that. Yeah. Not just one thing. And sometimes it turns out that if we want to act ethically, we need to sacrifice maybe model performance if we want to comply with data privacy guidelines, if we want to keep our model fair. The other question, I think, is what goes into the model? What proxies are being used? So with questionable examples that I mentioned of machine learning being used in unfair ways, if you will, it's often that what the modelers think is relevant is being used. So use of questionable proxies. For example, credit score is being used more and more to predict whether a given candidate will be a responsible worker and should be hired. Or, for example, when measuring how good certain schools are, proxy for how much students appreciate their education there is amount of donations alumni of a college give. Maybe it's more of a measure of how rich the alumni are than how good that education was. Things like that, yeah. So what goes into the model matters. Machine learning algorithms learn based on the data they're trained with. So if we give them poor features or unrepresentative data sets, of course, we'll have algorithms that favor some outcomes over others. And then I think the third question is this feedback that I already mentioned. How do we know that a model is working? How do we know kind of what its outcome is causing? We need that feedback. A lot of ethically questionable data science applications lack this unbiased feedback or testing. As we saw in the couple examples I gave, algorithms lack sort of internal ability to test their own assumptions. And in many instances, they also lack the ability to check whether they are making accurate predictions. So machine learning algorithms that do not receive appropriate feedback about their performance are not kind of being kept in check. We cannot simply put machine learning algorithms in place, just put them in production and use them and just expect them to work well. That's kind of what they did in the example of in the DC schools. Yeah. As in, let's just put it out there and just expect it to work well. It was trained on data, so it must be fair. So if there's a teacher that is praised by the principal and the community and all the students love them and say that they're doing great, well, that must be a manipulative teacher. The data set that they're not doing well, so we're going to fire them. Yeah, we cannot simply put a model in place and use it and expect that it works well. It has to have that feedback. Algorithm development is iterative and depends on constant sort of cycle of feedback, evaluating and tweaking the model to get best performance. All of that said, if that feedback is not appropriate, though, if it's a biased feedback, that can also be the cause of the problem, especially if you have algorithms that are written in such a way that they are constantly retrained based on the feedback that they basically are getting, right? If you keep collecting the data based on the examples on which you apply your model, then your models are selecting the data they're being trained on, and then the models are just perpetuating what they're predicting. So in the case of biased feedback, that's actually the cause of the problem, partly. So failure to sort of provide appropriate feedback or evaluate the model performance is what the problem is, and that can result in discriminatory or kind of unjust results. At this stage, I would like to mention the Oxford Munich Code. So if you're curious, I invite you to check that out. It's basically an initiative to define a code of conduct for professionals working with data science teams or working in data science. It addresses common ethical dilemmas that data scientists from the industry and academia may face. And some of sort of the advice I kind of picked out here, just a couple of them. So when it comes to algorithm fairness, what can we do to not perpetuate bias and not use machine learning models that are unjust or unfair? Is we want to make sure that your training data basically is fair and representative, and ask yourself if we've checked for any possible sources of bias. You kind of having bias in mind is already kind of a big part of this. Of course, it's also important that the team is diverse, that the team reflects diversity of opinions, as it says here, backgrounds and kinds of thought, so that if the data science team is diverse, it will be easier for people to kind of spot different things that may be problematic. And also testing for fairness with respect to different user groups if we deploy our model. Yeah, those are kind of the questions there. And in terms of data privacy, the things that you kind of would want to ask yourself is, do we have user consent? What kind of user consent do we need for the data that we would like to collect or use? Do we have mechanisms for gathering consent? Are users informed about what they're consenting to? Are we being transparent enough? And do we have a plan to protect and secure that data? How is the data going to be stored? What is our sort of security procedures there? So this is just a little glimpse of it. And I should also say that the field as such has quite some gray zones still. So it's something that's kind of still being created and it's being more and more part of, I guess, something that's on everyone's radar. So with that, I just want to say that if your role includes data analysis or writing or training or handling any machine learning algorithms, consider how they could potentially violate any of these ethical principles I mentioned today. So as I said, there's still many gray zones, but data ethics is here to stay. It will likely become a key part of responsibilities of data scientist's job. And it kind of already is to some degree. So United States will likely follow and sort of have some future implementation of a version like the GDPR in the European Union. But basically, while data science and specifically data collection and sort of building any machine learning models on its own, it's of course not inherently unethical in any way, shape, or form. There are just many kind of practices you should be aware of in order to just save your organization from legal issues or reputational issues or things like that, and B, just in general. And in my opinion, this is maybe as important, if not more. Try to use data science for the greater good in ways that are fair and just to everyone. And I hope to have kind of convinced you with a couple examples here that you should not assume that that's a given.
Thank you so much, Ana. Well, if you have questions for Ana, she will stay on. Our Q&A is open, so please drop your questions in there. We'll open it up to questions. I think a lot of these are going to be directed towards you, Ana, but this first question here is, why do you believe in building information age literacy and skills, and what huge social functions do you see becoming accomplished?
I'm not sure exactly what Eric has in mind there for in terms of, do you mean believing in building your skills as data scientists, or just kind of in general information age literacy and skills across the kind of general population where everybody should be able to have a little bit of those skills? I'm assuming you mean the latter based on the second question you asked there. So in terms of just building skills as data scientists, I think it's a good idea to have people have these skills, given that they are very much in demand and that you can do a lot of good with it, while also get a job easily because there's a lot of demand for data scientists. But in general, if you're talking about just building kind of digital skills and literacy in people in general, and having everyone have these skills, just because basically it would mean equality, right? Or it is inequality when only certain people have it. We live in a digital age that's not going to change. So certainly I think that giving people those skills is very important, because otherwise they're left behind. So certainly I would say that the first thing that comes to mind for me is just kind of equality in having people, have that opportunity to learn that.
We have another question here. So it says, thanks for the great talk. What do you think bears the responsibility for training data science, or who do you think bears the responsibility for training data scientists and data ethics? Data scientists, companies, academia, government, etc.
I'm going to say all of those. I do think that certainly it's on data scientists alone to some degree, certainly to be aware of that, to learn them themselves, but certainly companies employing data scientists, I think, would definitely have to sort of put emphasis on this part as well, and have some training and some focus on that. But I would also say that it should be part of programs, and I think it is more and more sort of that there's that topic that's also just in education of data scientists, that it's included. But I would say everything you listed. So I would say yes, from data scientists themselves, exactly, the companies where they work, to yes, government as well, I would say.
And then our last question in here, can you say more about population skew considerations and how data scientists can ethically increase literacy? For example, Twitter as not a representative sample, what platforms attempt to accomplish equity in their membership, and how do the big companies attempt to address this?
I think if I understand your questions correctly, you're referring to the fact that the fact that Twitter is not a representative sample means that people are not using it equally. And are there any pushes for that happening? Do big tech companies kind of address the fact that not everybody uses Twitter or other digital services? And I don't believe so. Not to my knowledge that Twitter or TikTok or Snapchat would be interested in kind of, other than for business financial reasons, to spread so that everyone across, let's say, the different kind of layers of society would use it. And I don't think that there's a push for that in general. So if, as a data scientist, you're looking for a representative sample of, it's very difficult to get one. So there are certain pieces of information that, for example, there are things like the census or some other things where basically people are asked certain questions across the board, across the country. But otherwise, most of the apps or digital services will have some segment of the population that uses it, and you need to be aware of that. And again, I'm not aware of any companies having, other than for spreading to more customers, have this particular kind of thing in mind to increase that literacy, to increase that everybody knows how to use it and that uses it for the purpose of kind of equity in their membership. Not that I know of. Yeah.
Those are all of the questions we have time for today. If we didn't get to your question, or if you didn't get a chance to type it in there, please email us. Again, admissions@thedataincubator.com. I think that email is in the chat. We'll be happy to answer questions about the program or forward some of your questions to Ana about the presentation today. But I want to thank Ana again for your time. We really appreciate when you're able to join us. You give such excellent presentations. And thank you, everyone, for joining us today. We hope you have a great rest of your day.
Thank you so much for joining us on this episode of Data Chats. And to our listeners, you can harness the power of your organization's data with Pragmatic Institute's course, Business-Driven Data Analysis. Learn a proven and repeatable approach you can leverage across data projects to deliver timely data analysis with actionable insights to power business strategy. Learn more at pragmaticinstitute.com/data, or speak with our sales team about scheduling a private training tailored to your team's needs.